solve the roller coaster physics problem. Here we're going to be creating a roller coaster that has a loop in it, and we know the loop has to have a radius of 18 meters. So we're going to figure out what speed the roller coaster is going to have at the very top of the loop in order for the riders to experience a moment of weightlessness. We have our picture already drawn. So we have our loop. At the very top, the only force acting on the car is going to be gravity. There's going to be no normal force because in order for the riders to feel weightless, they need to leave their seats for just a moment of time, just an instant. So in that instant, there is going to be no normal force. And we know that the radius is 18 meters. So in this particular problem, we'd look and say, okay, what force is pointing towards the center of the circle? Because that's our centripetal force. We only have one, and that's the force of gravity. So the force of gravity is our centripetal force. From here, we know that the force of gravity is given by mass times g, which is 9.8. And we are looking for how fast the car is going to be going. So I'm going to use the version of centripetal force that has velocity in it, which is mv squared divided by r. From here, hopefully you can see that there's a mass on both sides, so we can divide those out and they cancel, leaving us with gravity equals the velocity squared divided by the radius. Finishing up, we're going to solve for the velocity, and we get g multiplied by r equals the velocity squared. So we take the square root, and we get the square root of g times r equals our velocity. Now we just have to plug in our numbers, and we are done. G is, as always, 9.8 meters per second squared. The radius of the loop is 18 meters. And when we plug that into the calculator, what we will get is that the roller coaster has to go 13.3 meters per second at the top of the loop for the riders to feel a moment of weightlessness.